CMAC or HMAC, which is better? In cybersecurity, there are many acronyms, and to be an expert, you really need to dig underneath the methods and understand how they work. One weak area in the industry is in the usage of MACs, or Message Authentication Codes. With public key signing, we use a public key and a private key, and where the private key will digitally sign a hash of a message, and where the public key is then used to verify the signature. With a MAC, we use a shared symmetric key, and where Bob and Alice will have the same shared secret key. HMAC. HMAC is a message authentication code that is used to verify the integrity and authentication of a message. It involves hashing a message with a secret key and thus differs from standard hashing, which is purely a one-way function. As with any MAC, it can be used with a standard hashing method such as MD5, SHA-1, SHA-256, and which results in a method such as HMAC MD5, HMAC SHA-1, HMAC SHA-256. Also, as with any other hashing method, the strength depends on the quality of the hashing method and the results and the resulting number of bits in the hash code. Along with this, the number of bits in the secret key is a factor in the strength of the hash. In the figure I've outlined on the related blog post, we can see that the message is sent and is converted with a secret key and a hashing function to produce an HMAC code. This is then sent with the message. On receipt, the receiver recalculates the HMAC code from the same secret key and the message and checks the received version. If they match, it validates both the sender and the message. With OpenSSL, we have a wide range of MAC methods, such as Blake 2B, MD5, SHA-1, SHA-224, SHA-256, SHA-3, Shake 128, Shake 256, and SM3. CMAC. CMAC, or cipher-based message authentication codes, create a message authentication code using a block cipher and a secret key. They differ from HMACs in that they use a symmetric key method for the MAC rather than a hashing method. When the recipient receives the CMAC field, they will also compute the same CMAC with the message and the same shared secret key. If they are the same, the recipient knows that the message has not been changed and has been signed with the secret key. In the related blog post, I've added some coding using Google Tink. MACs with stream ciphers. There are many MACs around, including HMAC, GMAC, CMAC, Blake 2B MAC, Blake 2S MAC, KMAC 128, and KMAP 256. One of the core applications of CMAC is in authenticating a cipher stream, such as with AES GCM. If we did not use a CMAC, an adversary can flip the bits of the cipher and change the decrypted output. Conclusions. And so the answer is that HMAC is a hashing method and CMAC is a symmetric key method. Overall, HMAC is simpler and faster than CMAC. It is normally the best choice for varying lengths of message and for different key sizes. CMAC, though, is possibly better at complying with standards and in integrating with a wide range of protocols. Thank you.